Calculus 8.5, this will be the last lesson of our career together. It's been fun. Wish we could do this in person because it's more fun in person. But 8.5 is about a thing called integral tables. So I sent home with your most recent pickup day a paper that's titled A Brief Table of Integrals. Basically imagine this to be a super giant sized note card version of integration rules that can do a variety of integrals. And you might think this is not a very brief table because it has 118 of them. But I can tell you a Penn State related story that I lived with a guy that was an aerospace engineer. And he had an integration table that was about like a book like this size. And it had like over 100 pages of integrals. So if you look at yours, you can see they grouped them into similar looking ideas. Like page 1 is mostly integrals that have square roots in them. If you look at page 3 is mostly like integrals that have trig stuff in them. His book had like chapter 1, integrals with sine, and it would have hundreds of them. And then chapter 2, integrals with cosine, hundreds of them. Then integrals with sine and cosine. Then integrals with tan. Then integrals with roots on the bottom, or integrals with roots on the top. It was the same idea as yours, but it was much more extensive. So yours actually is fairly brief, even though it's up to 118. The most difficult part of the homework is usually just figuring out which problem it is, which one on the list. So the first example, the thing that catches my eye is this little -1. So when I go through this problem, through this paper, I'd go skimming for something that has a little -1. And I start to notice that happening around 6, 8, 9, that kind of thing. It's not 6 because it has an X in front, and 6 does not. So it has to be probably 8. And we do a careful look over there, and it is 8. So what that tells you is that the 2 is in the A position, the 5 is in the B position, and then you just make that answer happen. The answer has X over A, so you would put X over the 2. Minus B is 5 over an A squared, which is 4, ln, and in bars, they just have a repeat of that same thing, plus C. And that's all we need to do with that. For the example 2, the thing that catches my eye is that there's a root on the bottom, but we also need to be careful that there's going to be an X around. So if we look for things with roots on the bottom, I start to notice that happen here. 13 and down has a few of those. 13 itself does have the X here that we're after. But there's a 13A and a 13B. If you look to the end of 13A, it says that this B would need to be a negative number. B is less than 0. And that's not the case. So this is 13B. It can be helpful both to you and to me in communication later. Write down which pattern you thought it was. Even if you're talking to each other, you could be like, did you think that one was 13B? I thought that was 13A. I thought it was 15. I thought, if you write down which pattern you thought it was, life can be simpler. But for 13B, the 2 is the A position, the 4 is the B position, and then just make the answer. 1 over the root of B, the root of 4 is a 2. ln, bars, big fraction, minus and plus at the end. The root of B is at the end again, so there's 2's. And then the original root from in the problem is just going to get copied in there with our friend the plus C. Example 3 is almost the same, but they changed this to be the negative that we looked at in 13A and rejected, but now we're going to embrace 13A. This is the A. The B would be a -4. So if we do 13A, we have a fraction with 2 over make this a sign change to 4 and root it. That would be a 2, but I refuse to write 2 over 2 in the long term. Then it's inverse tan, a root. This part is just reappearing. The 2x minus 4 is still there. The bottom, they want us to switch the sign of the 4, do a plus c. Keep your eyes peeled for things that you can make a little bit better. This would be a better answer in my opinion because we can divide those all by 2. The book, did they do that? Yeah, they did that as well. So that's good. This looks almost the same, but it isn't. This one has an x squared. So we're probably roughly in that same area. 15 has an x squared. And 15 doesn't have an a or b because it just doesn't matter. The a is the 2, the b is the negative 4, and then we're going to just follow the trend here. So we'd have negative, the root that was there at the beginning, on top of a negative 4x, negative and negative will make positive in my world, minus an a of 2 on top of a 2b, which is a negative 8, minus minus makes plus, 2/8 feels like a reducing thing I should do, and then a new integral, dx over x root 2x minus 4. This, we already did. We just did that right here. So if we took this answer and stuck it there, then that problem's done. Sometimes you'll get an integral that leads you to another integral. 15 leads you to 13a again. That can happen. For example, 5, we need to find our way to some trig world. So that's clearly not on page 1 or 2. Probably on page 3, but we're looking for this little negative 1 on the trig stuff as well. And so I'm not seeing that either. And I'm looking then at the back page. I'm starting to see the little trig negative 1 at 96, but I also need an x there. So then I'm looking at 99, because 99 works with x to any power. Make sure the book agrees with me. They do. They say that's problem 99. So the n would be the 1 that's unwritten there. The a is a 1 that's unwritten there. And so then we cut to the answer. We'd have x to the n plus 1 over n plus 1, inverse sine, ax minus a of 1 over n plus 1 is 2, new integral, x to the 2 on top of a root 1 minus x squared. Then we'd have to look to see where that goes. So that one, we're back to a rooty page. Root on the bottom, x squared on the top. There was nothing like that on page 1. Page 2 has that. A lot of roots and things. If we're going to go numbers minus x's, this fits the pattern for 33. So for 33, we would use an a of 1. So I'm going to just clear this out. And a half is going to go with everything that 33 steers us to, which is an a squared over 2, inverse sine, x over a, minus a half, an x, a root, 1 minus x squared plus a c. I would distribute this negative half in to make these be fourths and change some signs, and that would be our best possible answer. 10 to the 5th, I'm back to the trig page. Probably page 3, 10 to powers, there it goes, I'm thinking 86. So what this will make, we have an n of 5 and an a of an invisible 1. So I'm going to go 10 to the 4th, because of the n minus 1, over the a of 1 doesn't matter, n minus 1 is a 4, minus new integral, tan, down to 3 with an x. I'll clear this out to make a little space. To do this problem, I'm going to need to use that same number 86 again. So like that's still part of the answer, minus, if tan 5th just became tan 4 over 4, tan 3 is going to need to be tan squared over 2. So I'll shade that a little bit. There would be a minus, but this minus would hit the other minus to make a plus for my new integral. And if this went from tan 5 down to tan 3, this one must just be down to tan. Now I look for that, that's actually on our card. Or it's also on number 82, which would get us ln absolute value secant x plus c. So we get that, sorry for the awkward circle. So we have this still there, minus this still there, plus this new thing that we just created. That would all be the answer for that one. For the last one from example 8, we'd be looking to do, let's see. They're lying on example 8, so I'm just going to skip that one. I think you have the point. But when I look at the book at the example 8, they say to use equation number 3, and that's definitely not number 3 on this list. So I'm not sure what they're talking about there for a second. But I think you have the gist of what we're doing. You look at the problem and you find a problem that fits that form, and you just go for it. I think it's very helpful for communication purposes to write down which number you were using. Sometimes you get to use the same problem, the same number like twice in a row. Sometimes one leads you to another. Sometimes you just do one quick hit and you get out. That's what you're rooting for. So we're here for 2 days. The first day we're doing the 3s, 3, 6, 9, 12. And then the last day we're doing the next problem up from that. So doing 4, 7, 10. Etc. So if you need more help, we'll zoom it out. See ya.